Okay, our group consists of 5 people, consisting Iqbal Abdillah, Iqbal Fatwanto, Firman Rizky F, Zulfikar Ali R and Muhammad Syauqi Al-Haqqi. Next. First material will be presented by me. It's about linear circuits, basic audio frequency amplifiers. Next. First, introduction. Linear or analog circuits are amplifier type circuits. They handle signals that are electrical representations or analog of physical quantities which vary continuously with same time and take on a value between a certain maximum and minimum. The information carried by such signals is in the amplitude and shape of their waveforms. Voltage amplifier using a junction transistor. Although a junction transistor in the common emitter mode is basically a current amplifier, it can act as a voltage amplifier if a suitable resistor called the load is connected in the collector circuit. The small alternating voltage could be amplified. The input voltage Vi is applied to the base emitter circuit and causes small change of base current which produce large change in the collector current flowing through the load. The load converts this current change into voltage change, VO being much greater than Vi. Next, please. To see in more detail this way voltage amplification occurs, consider first the situation when there is no input is E times E times Vi equal to 0, called the quiescent state or quiescent means quiet. Next, please. First, quiescent state. For transistor action to take place, the base emitter junction must be forward biased and has to remain so if when Vi is applied and goes negative. As we saw in unit 3.3, as we saw in unit 8.3, a simple way of doing this is to the base bias resistor as shown. A steady, D point C. Base current IB flows from plus VCC through RB into the base and back to zero voltage via the emitter. The value of RB can be calculated. See unit 10.3. Once the value of IB for the base is next please. Okay. As we can see in this picture, if VCC is the power supply voltage and VBI is the base emitter junction voltage, always about plus 0.6 voltage for an NPN silicon transistor. Then, for the base emitter circuit, since D point C voltage at all, we can write VCC is equal to IB times RB plus. Next, please. IB causes a much larger collector current ICU, which produces a voltage drop IC times RL across the load RL. The voltage at the end of RL joined to plus VCC is fixed, and so the voltage drop must be at the emitter voltage. Then for the collector emitter circuit is plus VCA. Next slide, please. Okay. Component values are chosen so that the steady base bias current IB makes the quiescent collector emitter voltage VCA about half the power supply voltage VCC. This allows VO to have its maximum swing capability, in theory from 0 voltage to VCC. Second, applied input signal. When Vi is applied and goes positive, it increases the base emitter voltage slightly. When Vi swings negative, the base emitter voltage decreases slightly. As a result, a small alternating current is superimposed on the quiescent base current IB, which in effect becomes a varying D point C. Next, please. Third, further points. The transistor and load together bring about voltage amplification. Next, please.
Next is
Load
load
lines
lines.
operate.
Yok, bagianku yok.
It's will be presenting
Next
by
is
Zulfikar Ali Rafsanjani. Zulfikar Ali Rafsanjani, the time is yours.
next is load lines, operating point, and voltage gain. When designing a voltage amplifier, the aim is usually to obtain a certain voltage gain, minimum distributor of the output, so that it is a good copy of the input, and operating within the current, voltage, and power limit for the transistor. The choice of the quest, the choice of the quiet or DC operating point determine whether this requirement will be met. This choice is made by constructing a load line as we will now see. Next, stability and bias. Next, first thermal runaway. If temperature of a transistor rise, there is greater vibration of the semiconductor atoms, resulting in the producing of more free electrons and holes. The collector current increase, causing further heating of the transistor until eventually the transistor is damaged or destroyed. The initial temperature rise may be due to the heating effect of the collector current itself, or to a rise in the surrounding temperature. Next, to stop this thermal runaway and affect the DC operating point, special bias circuit have been designed which automatically compensate for variations of collector current. Next, second, collector to base bias. The basic circuit of FIC 10.2 for a voltage amplifier can be adequately stabilized for many applications by halving the value of RP and connecting it between and base as in FIC 10.5 rather than between plus VCC and base. Next. And next will be read by Syauqi Al-Haqqi.
Okay, thanks. A simple two-stage voltage amplifier. When greater gain is required, two or more amplifiers are coupled. The circuit in Fig 10.6 is offer a two-stage capacitor coupled voltage amplifier using collector to base bias. Next, capacitor coupling. The output from is applied to the input of the R2 via C2, which connect the collector of the R1. It must have a quiescent DC voltage of plus 4.5 volts for correct operation, and the base of the R2 it is plus 0.6 volt above the emitter at 0 volt. Being a forward biased junction, a direct connection without C2 would have the disastrous effect of fixing the collector of the R1 at only plus 0.6 volt above ground and would also send a base current of several millimeter ampere into TR2 to 1 kilo ohm TR1 collector load that will saturate. Next. Number 2 is frequency response. The voltage gain of a capacitor coupled amplifier is fairly constant over most of the range, but it falls off at the lower and upper limit. At low frequencies, the reactance of the coupling capacitor increase, and less of the low frequency part of the input is passed on. At high frequency, characteristic capacitance in the active devices and the connection can cause the fault. Next, frequency response. In a fat voltage amplifier, change in the gate input voltage cause change in the drain current, which are converted into largest voltage change by a load resistor, one drain output circuit. Next. Next. To Firman can continue the presentation.
Okay, thank you, Muhammad Syauqi. This is more audio frequency amplifiers. This unit deals with a more extensive aspect of audio amplifier circuit design. Uh, fully stabilized voltage amplifier. When complete stabilization of the DC operating point is required, voltage divider and emitter bias is used. It has three main features. Number one is voltage divider or R1 and R2. The junction of R1 and R2 fixes the base voltage at a value sufficient to forward bias TNE base emitter junction, or in collector to base bias the base current was fixed. The current drop R1 and R2 is usually made about 10 times greater than the quiescent base current, so that with the latter phase with the input, the base voltage is hardly affected. Number two, decoupling capacitor or CE. When an alternating input is applied, the collector and emitter currents become very DC and EA. They consist of CD, DC plus AC. The large capacitor CE across RE offers an easy path for the AC. The combined impedance of CE and RE in parallel is negligible to the AC and the AC voltage across and the A and C voltage across them is also negligible. Without the CE and AC voltage would be developed across RE and reduce the gain considerably. Number three is a further point. The output voltage in this circuit can swing only between VCC and VE instead of between VCC and ground. The value of Re is therefore chosen so that VE is about 1/5 to 1/10 of the supply voltage VCC. Um, this presentation will be read by Muhammad Iqbal Abdillah. Muhammad Iqbal Abdillah, this time to yours.
Okay, negative feedback. Next, please. First one, advantage. Out of negative feedback or NFP, reduce the gain of an amplifier and may necessitate more stage of amplification. It has several highly desirable effects. This can be predicted from theoretical considerations. For our purpose, it is enough to know that they include: first, increase the stability of the overall gain, i.e., the gain is less affected by change of transistor parameters, e.g., and by variation of temperature and supply voltage, and less distortion of the output, and then greater bandwidth, i.e., a wider range of frequencies is amplified by the same amount. And then the the last one, alteration of the input and output impedance of the amplifier to almost any desired values. There are various NFP circuit, only two common ones will be considered. Next one. Two, full patch feedback. The collector to base bias circuit of the junction transistor voltage amplifier of FIG 10.5 is shown again in FIG 11.4 with the alternating components of current smart. Resistor RB provides not only the quiescent or DC base to the base emitter junction, but it also applies the voltage negative feedback of the AC input as follows. Next, please. And the current feedback, this type is used in the VET voltage amplifier of FIG 11.5. The circuit is the same as FIG 10.8, but with the source decoupling capacitor GS emitter CS. Next, please. Equalization and tone control. Equalization and tone control by frequency selective NFP in sound reproduction. The electrical signal applied to an AF amplifier may not be a faithful representation of the original sound because the input transducer does not respond equally to all frequencies. To compensate for this, the amplifier has to push some frequencies more than others. The process is called equalization and is achieved by using a NFB circuit whose impedance is not purely resistive, as in the two previous cases, but depends on the frequency. Next. Input and output impedance. The input and output impedance are two other important properties of an amplifier. The input impedance Zin equals Fin or Lin, where Lin is the AC input current when Fin is the AC input voltage. It depends not only on the input resistance Re of the resistor, but also on the presence of capacitors in the circuit. Next. The output impedance Z out is the AC equivalent of the internal or surge resistance of the battery. It causes a loss of voltage at the output terminals when another circuit or device is connected to them. There is the output side of the amplifier behaves like a voltage generator and its terminal voltage on closed circuit is less, the greater the Cout is. And on open circuit, as in the DC case, both Cout and Zin can be measured in ohms experimentally. Next. Okay, that's all for me. And times and place back to you, Fatwanto.